is Mike Panaki with Network Protocol Specialists. And in this section, we're going to take a look at the three-way handshake and the initial HTTP GET when we go out and get an image off a web page. And starting up here at the top is where we have our TCP SYN packet. And this is our synchronization packet, and it's the first packet of the three-way handshake that's used to set up every TCP conversation. So in this case, we send our SYN packet, and we send the destination end. Now in this case, this is networld.com, our initial TCP sequence number. Now if we look at this example right here, we see that this TCP sequence number ends in 604. In addition to our initial sequence number, we send our TCP window size, that's going to be our receive buffer, and our maximum segment size. This is the maximum number of bytes that we can put in any one TCP packet. We send that off to networld.com. What we get back is a TCP synchronization frame from networld. Now if we come over here and we look in the delta time column, this tells us how long did it take to get that response from networld. And in looking at this case, it took 93 milliseconds from the time we sent our TCP SYN to when we got a response. We come over here and we can see that networld is telling us what its initial TCP sequence number is. And this one ends in 8771. If we look at the acknowledgement number, we can see the acknowledgement number ends in 605. So what we'll see is that in the beginning, where we're not sending any data, the other end lets us know it received the packet by incrementing that sequence number by 1. It gives this our initial TCP sequence number, or TCP window size, which in this case is going to be 65,535, and it's advertising a maximum segment size of 1,412 bytes. So that's the maximum amount of data that we can send networld in any one packet. In response to that TCP SYN acknowledgement, we send a TCP acknowledgement letting networld know we received its TCP SYN. And just as it incremented our TCP sequence number by 1 to give us an acknowledgement number, we too increment the TCP sequence number by 1. So in this case, we go from 8771 to 8772. Now one thing you'll notice in here is that our analyzer is reporting back to us that the TCP checksum is incorrect. And that is the case. If we were to drill into this frame, we would see that this TCP checksum is incorrect. And that's because on my laptop, I'm implementing TCP checksum offloading. This means that the TCP layer of the protocol stack does not calculate this checksum. Instead, the TCP checksum is calculated by the network interface card before the frame is sent out onto the wire. After we send the acknowledgement, we then send our HTTP GET. Now in this case, our HTTP GET is looking for netflash.js, so we're looking for a JavaScript. The server then comes back with a TCP acknowledgement. Now it's important to note at this point the server has not returned any data to us. The server is simply acknowledging that it received that HTTP GET and that it's acknowledging that TCP frame that it received. Now if we come over and look at our delta time, we see that that came back to us 98 milliseconds after we sent it. Then 1.9 milliseconds later, we actually see our response to our HTTP GET. So this is a case where the TCP layer, our transport layer, is letting us know that the packet was received, but the application layer wasn't ready to send us a response yet. So this gives you an idea of what the TCP three-way handshake looks like and what an HTTP GET looks like where the server end wasn't ready to send us data back right away. So I hope this helps in your troubleshooting, and as always, we're happy to help you out and help you fix your problems. Again, Mike Panaki, Network Protocol Specialist.